These are notes for Solutions Worksheet number 2. Ways to look at concentration. Mass percent, percent by volume, and molarity. These are all ways to interpret concentration. We're going to look at mass percent first. The mass of solute present in a given solution. The formula is mass of solute divided by the total mass of solution times 100. The best way to write this is grams of solute divided by the grams of solute plus the grams of the solvent. The grams of the solute plus the grams of the solvent is the total mass of the solution. Mass percent practice. This is from worksheet number 2, and this is problem number 5. It says calculate the mass percent of 2 milligrams of calcium chloride dissolved in 0.038 grams of water. So we need to grab our writing pen. There we go. Alright, this is number 5. So mass percent equals the grams of the solute. That's the thing that's going to be dissolved, divided by, I'm going to put parentheses here, the grams of the solute plus the grams, squeeze them really close there together, of the solvent, times 100. So let's plug in our numbers. We have grams of solute, calculate the mass percent of, here are our grams of solvent, 2.00 milligrams. I'm going to repeat that on the bottom, 2.00 milligrams, plus the grams of the solvent, which is the water, and that's in grams. We don't want it in grams, we need it in milligrams, so I'm going to move the decimal 1, 2, 3, because it's 1,000, so we moved it to reflect 1,000. 38.0 grams times 100. So you add at the bottom and divide it into the top and multiply by 100, and you get a 5% calcium chloride solution. And that's the final answer. And you have to have 3 sig figs because all those numbers there have 3 significant digits. We'll move on to the next slide. Practice. We're going to do problem number 8 from worksheet 2. Let's see, is it here? It's ginormous. It says a hexane solution contains impurities that are 5.2% heptane, 2.9% pentane. Calculate the mass in grams of each component, that means all those things, present in a total of 93 grams of the solution. So this is a mass percent problem. So what we're going to do is take the 93 grams and we're going to multiply it by 5.2%, which is really 0.052. We can't leave it in percent form. And we're going to get 4.8, and that'll be grams, and that will be of heptane. So of the 93 grams, 4.8 grams of it is heptane. Now we'll take 93 grams again, and we'll multiply it by 0.029. We took 2.9% and changed it into decimal form, and we multiply those numbers together, and we get 2.7 grams of pentane. And we still have to find hexane. So hexane, we're going to have to do a little bit of subtraction. We're going to take the 93 grams total, subtract out 4.8 grams, and then we're going to subtract out 2.7 grams, and that's going to give us 86 grams for the hexane. So it's mostly hexane, but there are some things in there that are not hexane. That's all she wrote. Now we're going to do percent by volume. It's the amount of liquid solute dissolved in a solution. Liquid in a liquid. Sometimes it could be a non-liquid in a liquid. Volumes of liquids are not always additive due to differences in sizes between the molecules. For example, if you have 2 milliliters and 2 milliliters, it doesn't necessarily add up to 4 milliliters because sometimes one of the solutions fills in gaps in the other solution and they end up being less. For example, if you poured sand into a jar of marbles, the sand doesn't just fall neatly on top of the marbles and layer, it falls in between the air spaces and the marbles. So here's the formula. Grams of solute divided by the volume of solution in milliliters times 100. We're going to do problem number 2 from worksheet 2. This is, at first appears to be a tough problem, but it's not so bad. So a beaker contains 12 grams of salt dissolved in 75 milliliters of water. Suppose we do the following. We add 50 milliliters of pure water to the beaker and stir up the contents. And then B, we pour 5 milliliters of this new solution from the beaker into an empty test tube. And the question is, how much salt will be in the test tube in grams? So show your work and your units. I'm going to grab a pen. So what we do know, we have 12 grams of a salt in 75 milliliters to start with. But it said that we actually added 50 milliliters to the original 75. So that equals, if you add them up and then divide, you get 0.096 grams for 1 milliliter. So if you have 5 increments of that, you could add 0.096 up 5 times, or you could simply just multiply by 5 because you have 5 milliliters of it. Look at this. The 5 milliliters cancels those milliliters, and you end up with 0.48 grams of the salt in the test tube. Can you see that salt? Not necessarily so with your eyes, but it is in there, and it would probably taste salty. Those are the end of the notes for worksheet 2.